Okay, hello everyone. In this video, we are going to discuss about integration of Laplace transform and its corresponding numericals. Okay, this one and this one. In our last class, we have been discussed in detail about derivative of Laplace transform and corresponding numericals. This class, we are going to discuss integration of Laplace transform. So let's start. So this is the another property, G number. Okay. Last one was your f g. So integration of Laplace transform. If Laplace transform of f of t, small f of t equal to capital F of s, then integration s to infinity capital F of s ds will be equal to Laplace transform of 1 by d into f of t. So here proof starts. We know that Laplace transform of small f of t will be written as capital F of s. That implies capital F of s is nothing but 0 to infinity e to the minus st into f of t dt. Let this is your equation number 1. Now we are going to integrate equation number 1 with respect to x, s, both the side. Then this will be, and limit we are going to consider s to infinity. S to infinity capital F of s ds, s to infinity this much with respect to ds integration, and this is nothing but 0 to infinity e to the minus st f of t dt, right? Here what I done, that f of t taken outside and we considered inside this bracket s to infinity e to the power minus st ds and dt. I just exchange the integration. I taken this integration initial and this integration inside the bracket. That implies s to infinity f of s ds will be equal to 0 to infinity f of t is there, integration of this one with respect to s. So t will be constant, minus t will be constant, so e to the minus st by minus t, s to infinity is your limit dt. Now here infinite, if I am going to put over here, this will be e to the minus infinite minus s means e to the minus st divided by minus t. 0 to infinity f of t dt is there. 0 to infinity f of t into, here e to the minus infinity is nothing but your 0. So here minus minus plus e to the minus st by t dt. That implies f of s ds integration from s to infinity is equal to 0 to infinity e to the power minus st into here 1 by t into f of t dt. So this is nothing but Laplace transform of this function. So that implies s to infinity fs ds, capital Fs ds integration will be equal to Laplace transform of 1 by t f of t, hence proved. So you have to remember this one. Here one thing I am going to tell to you, that this integration of Laplace transform property also called as division of t property, also called as division of t property, division of t property, t property, because here whenever we are integrates, it divides 1 by t with the corresponding function. And derivative of Laplace transform, this one, derivative of Laplace transform also called as multiplication of t property. This is also called as multiplication of t, small t property. Why it is? Here you can see each time derivative with of a Laplace transform, t is multiplied with the initial function. Okay, so hence it is called as the multiplication of t property, and this is called as your division of t property. Okay, division of t property. Here you can write, or this one you can write over here, no problem. Now we are going to go for the numericals based upon this integration of Laplace transform. So find out Laplace transform of 4t by t. Solve using integration of Laplace transform. So we know that according to integration of Laplace transform s to infinity f of s ds is nothing but Laplace transform of f of t by t. where Laplace transform of f of t is nothing but this f of s, right? Now, as per the question, f of s is nothing but Laplace transform of this sine 4t. Okay, here if I am going to compare this and this, then here Laplace transform of function f of t by t. Here f of t by t means f of t is nothing but sine 4t. So first we have to find out the Laplace transform of sine 4t to find out the capital f of s. So Laplace transform sine 4t will be equal to 4 by a square plus 4 square, because sine 80 Laplace transform is your a by a square plus a square. So here a is 4, so a square plus 4 square. Hence Laplace transform of sine 40 by 40 will be equal to s to infinity according to this property. Using integration of Laplace transform, here I considered that Laplace transform of sine 40 by t will be s to infinity. This is the f of s of this function sine 40, 4 by s square plus 4 square into ds. So here we are going to integrate this one. So if I am going to integrate this one, that is your 4 is constant taken outside, so ds by s square plus 4 square. If I am going to integrate this one, then I am going to find out 1 by 4 here ds by a square plus 4 square. So it will be tan inverse. So that means 1 by a, 1 by 4 tan inverse s by 4 s to infinity. Limit is already there, s to infinity. So now we are going to put the limits. So here 4 got cancelled. Tan inverse infinite minus tan inverse s by 4. So tan inverse infinite is nothing but pi by 2, because sine pi by 2 by cos pi by 2. Sine pi by 2 1 by 0 infinite. So this is tan pi by 2. Tan pi by 2. So tan inverse infinite will be pi by 2 minus tan inverse s by 4. So here finally we found Laplace transform of sine 4t by t will be equal to pi by 2 minus tan inverse s by 4. This is your required answer. Next, Laplace transform of cos 80 minus sin bt by t. This is somewhat important question that you have to practice for your exam. According to integration of Laplace transform, we know that s to infinity f of s ds is your Laplace transform of f of t by t. Here f of t is a small f of t, where f of t, so Laplace transform of f of t is nothing but capital F of s. Comparing with the question, if I am going to compare question with respect to this one, here f of t is nothing but cos 80 minus cos bt. So now to find out this f of s, to integrate, first we have to find out Laplace transform of the given f of t. Laplace transform of given f of t is your cos 80 minus cos bt, cos 80 minus cos bt. So Laplace transform of cos 80 is nothing but s by a square plus a square minus cos bt will be s by a square plus b square. So here at means a square plus a square, bt means a square plus b square. That implies Laplace transform of this by t will be equal to how much? Here we applied the Laplace integration of Laplace transform. Applying integration of Laplace transform. That Laplace transform of cos 80 minus cos bt by t will be equal to s to infinity integration of Laplace transform of this one. Already we found this one. So s by a square plus a square minus s by a square plus b square ds is equal to s to infinity. Here what I done that 1 by 2 I multiplied, and 2, that means 2 I divided, 2 multiplied with each term. So 1 by 2, 2s by a square plus a square, and 1 by 2 taken outside. So this will be 2s by a square plus b square. Okay, if I multiply 1 by 2, then I am going to get the same. Okay, so here you can see that the denominator derivative we can found in the numerator. So if I am going to derivative of a square plus a square, we found 2s. So hence integration of 2s by a square plus a square will be ln a square plus a square. Okay, so 1 by 2 taken outside, integration of 2s by a square plus a square will be equal to ln a square plus a square minus, likewise this will, integration of this one will be ln a square plus b square. S to infinity is the limit. So equal to 1 by 2 ln a square plus a square by a square plus b square s to infinity. So this can be written as 1 by 2 ln I divided a square with each term, then ln 1 plus a square by a square by 1 plus b square by a square, s to infinity. Now we are going to substitute the limits. First limit I have to put. If I put first limit, then a square by infinite is 0, b square by infinite will be 0, and we are going to get ln 1. So here this line completed here and starts from here. Okay, only for I mark the stars that here is the ends this line and here starts. So you have to write from this line. Okay, 1 by 2 ln 1. Whenever we are going to substitute infinite, then we have to substitute s. If I am going to substitute, then minus ln, same thing I have to write, because instead of s, same s is going to be substituted. So 1 plus a square by a square by 1 plus b square by a square. So 1 by 2 ln 1 we know that 0 minus ln 1 plus a square by a square, s square by 1 plus b square by s square. Okay, so here minus means this to the power minus 1, because we know that minus of ln x is nothing but ln x to the power minus 1, or we can write 1 by x, ln 1 by x. So here minus is there, means we can write ln ln 1 plus a square by a square by 1 plus b square by a square to the power minus 1, or ln this will be reverse, 1 plus b square by a square divided by 1 plus a square by a square. Okay, so if I am going to simplify this one, this will be how much? This will be ln a square plus b square, a square plus b square by a square, and a square plus a square by a square. A square will be cancelled out, so a square plus a square. So here finally we found half ln s square plus b square by s square plus a square. So here we have to stop our today's class. Next class we are going to discuss Laplace transform of unit step function, which is one of the important topic belongs to your Laplace transform. It has many applications. So next class we are going to discuss in detail. Okay. So thank you so much for watching this video. Thank you.